Our next speaker will be focusing on the critical role of intellectual property. Now, please welcome Ms. Jennifer Che, President and Managing Director of Eagle IP. Her topic is IP strategy as the cornerstone of medical innovation commercialization, lessons from global markets.
Thank you so much. Hello, everyone. It's really great to be here. I want to first start by introducing myself a little bit because maybe many of you don't know me. As an intro, so I moved to Hong Kong 8 years ago from the United States. And I often get asked, when I see people around, they say, "Oh, when did you come back to Hong Kong?" And I'll actually say, I'm not coming back to Hong Kong. I moved to Hong Kong. And this is because first I was born in the United States. And secondly, my parents are actually immigrants from Taiwan who moved to the US. 所以我说的普通话还是可以，但係我廣東話真係唔得㗎啦。So bear with, I don't have to speak Cantonese with you today, thankfully. We'll be doing this in English, but that is my background. And I did study chemistry, so I'm a scientist at heart. I've always loved science. I studied chemistry and worked as a medicinal chemist actually for 6 years before switching careers into patent law, which is what I'll talk to you guys about today. And I kind of have a reverse, I guess you could say, career story in terms of most patent attorneys because I started in-house. And that's a little bit different because I was starting at a large company, Vertex Pharmaceuticals, worked inside a company, met with scientists, talked about the business side of all these things, very strategic commercial stuff, right? Which is what we're talking about today. I started my career inside a company and then switched to working with startups, which is Excella. That's a startup, it's a flagship founded startup in Boston. And that's completely different. You're in a small company with limited funds. They have to raise money. And as a patent attorney who was trained in a large company where you have to do everything a certain way, all of a sudden I learned when there's not enough money, you can't just do everything like that. You have to be creative. You have to think about what's really important. So at Excella, I learned about startup life, how to advise on IP from that angle. And then moved to Hong Kong in 2017, and I've been at Eagle IP, so that's a Hong Kong-based firm, actually. I'm a U.S. patent attorney at a Hong Kong-based firm. We also have Chinese patent attorneys, of course. And there, it was a whole new world, right? There, I'm learning about Chinese patent law, about this Greater Bay Area, how to integrate U.S., China, global patent strategy in kind of Asia. So finally, and most people start this way, they start in private practice. I'm kind of reversed in that now I'm in private practice, providing services to all sorts of different types of clients. So I wanted to share with you that background because it kind of explains a bit about my strategic approach and why I think the way I do. And it is because I have this kind of US-focused pharmaceutical and biotech startup-y background and then coming back into Asia like this. So I just said back into Asia, and I should have said actually coming to Asia, right? Because I'm actually born in the States. I also IP is not all I do. I actually love food and travel. So if you care about food and travel and you want to connect with me that way, I actually write a food blog, and I also love music. So, we're all kind of beings that do lots of different things. So, of course, today I'm going to talk to you about IP. So, namely in this biomedical space, right? Which is what we're all here to learn about. Because biomedical inventions have a very unique, in some ways, a need for strategic thinking because they involve so many different areas. They involve cross-disciplinary areas where the idea of IP doesn't just involve patent law, actually. It involves a lot of different aspects. Therefore, understanding all of these areas is really crucial, and having a strategy right at the beginning is really important. Otherwise, you can make a lot of mistakes. So what do I mean by that? So let's just talk about bio, first of all, right? Biology, the human body is so complex. And it's also considered naturally occurring, right? Oftentimes we're making discoveries about correlations or relationships, or we discover a new molecule, a naturally occurring molecule in a plant, right? There's all this discovering what's going on in nature. And did you know that the patent law doesn't protect discoveries? Because you didn't build it, you didn't create it, you didn't invent it, you found it, right? Yes, you found something amazing, but you didn't create it. So you have to think about how to take that naturally occurring concept and translate it into something that's practically applicable. That is what inventions are. They're solutions. They're technical solutions to a technical problem, just like Professor Moria was saying, right? What is the problem that you need and what is the solution? So in this case, we have to think about this discovery. How do we translate it into a actual solution, and that's what you patent. So when you draft a patent application, you have to write it in the right way, complying with these rules. Otherwise, you will get a rejection that says, this is naturally occurring, it is not patentable. I don't care how amazing the discovery was, you didn't add enough of your own creative input. All right, so that's one aspect. So let's move on to diagnostics, right, or methods of treating a disease. This is very core to what we do. That's the purpose, right, of why we're all doing this research, is to diagnose and treat diseases or prevent, right? Unfortunately, in a lot of patent laws around the world, and every country is different, literally, you're not allowed to patent methods of treating a disease. China, the law says you cannot patent methods of treating a disease. The US, you can. So again, this is a law difference that you have to understand when you're drafting your claims. If you want to go into US, you should draft these claims. If you only want to go into China, you should not draft these claims. Same with diagnosis. Diagnostic methods, diagnostics have had a hard time in the US lately. You know, the law has been quite strict about that. But diagnostics are much easier to get in Europe. So again, if you're thinking globally, you have to think about, how do I draft these claims to best protect my product all around the world, especially if I'm in areas where the law may not allow me to protect this particular technology using this type of language. Let's think about another way. Well, it's not a diagnostic, it's also like, is it a system? What is it, right? And then we can think about that. Maybe it's the needle. The needle is not the diagnostic per se, but it's some physical object, right? So there's ways to think about that. And then I talked about how biology is so unpredictable, right? So in patent law, for example, you can think of an idea and maybe draw it down, right? There was Steve Jobs in our last presentation. Steve Jobs, when he was sick, he was drawing inventions. He was seeing problems around the hospital. He was drawing things down. Now, if you have a physical invention, typically if you draw it, you can kind of imagine, yes, I'll build it and it will work. So just a drawing enough might be sufficient for Steve Jobs to get that patent. But in the life science space, it doesn't work that easily, right? You draw a molecule and you're like, if I put that into a human being, is he gonna like not get sick and is he gonna be cured? I don't know, right? Yes, maybe my computer modeling shows that it might work, but if I haven't tested it in at least some kind of in vivo or in vitro model, I don't know for sure, right? So because it's known that this area, biology, chemistry, the human body, is not that predictable, examiners will require a lot more data to show that an invention works. This is called enablement. So when you are thinking about patent drafting, some people get all maybe greedy and they say, I want to own the world, and they draw all these things and then they file, because like, we need to file now. We don't have any data. We don't care. We have to stop, someone else from copying or coming up with the idea. So they draw all this stuff, they file it, and the next thing you know, it all gets rejected because you have no proof. And now what you've done is you've put your idea out there, it's been published, you can't take it back. Now everyone can kind of take it because you couldn't get the patent because you had no data to support. So if you're thinking about in the life science area, you have to be careful and think about how much data do I need to at least convince the examiner that I kind of have this invention. It's not just a wish list, it's an actual invention that I've at least proven through, it doesn't have to be 1,000 examples, but at least a few to show that I've got this invention works and I've proven it, give me this, scope. So these are just some of the issues that come up with life sciences. Let's talk briefly about the regulatory aspect, because as you know, in medicine, right, for diagnostics, there are regulatory approvals that need to be done. So oftentimes, you have to be careful about what you are saying to the regulatory department and what you are saying to the patent office, because they might be tempted to conflict. Now, you're not supposed to make conflicting statements, right? You're supposed to tell the truth. But imagine a scenario where somebody is working to submit some statements to the regulatory department, and they're saying, our product is substantially similar to the one before us, and therefore it is also safe. I don't have to run all these tests because it is substantially similar. This is a pretty common practice where companies want to save some money, right? They don't want to have to run all these tests. So if they make a statement that says they are substantially similar, they can potentially streamline their application. Now, unfortunately, that particular previous product has been out there, and a patent examiner has also said, you are not innovative because your invention's already known. And you say, no, we are completely different. We are technological advanced. We are so different because of A, B, C, and D. We are not similar. Guess what? You just told one government body that you're exactly the same. You told the other government body that you're completely different. And maybe in the past they didn't talk to each other, but literally, I want to say last year, the USPTO put on kind of like a stronger communication between the FDA and the USPTO so they can share this kind of information. At the same time, the China Patent Office, actually both sides are trying to crack down on fraud. And definitely patents have actually gotten invalidated for fraud because it was found out that they made conflicting statements knowingly to two sides. So this is something you want to be careful of. Of course, you can try to prove, oh, it wasn't knowing, this department didn't talk to that department. But if you were at a meeting or if there was proof that you were there and you should have known, you just don't want to have that risk, right? So it is much, much safer to have good communication between your regulatory folks, between your patent office folks, and to always know what's going on. So let's keep talking about different kinds of IP, because it's not just about patents, as I said. There are many ways to protect, and in this life science stage, there's a mix, and it can be quite complicated. Like, for example, trade secrets. My manufacturing process, right? Maybe it's hard to actually patent the whole process, because even if I patent it and someone uses my process, how am I going to know? Am I going to knock on their manufacturing door and actually go in and figure out what they're doing? Maybe it's hard to tell just by looking at the final product. So maybe it's not worth me patenting it if it's hard to enforce, and instead I should just not share it. Now, there's limits to this. The FDA might force you to release something, but there might be ways of keeping certain types of know-how trade secret, right? Life science has a lot of other nuances to protection. There's what's called market and data exclusivity. These are regulatory protections that have nothing to do with patents, but it's another way to keep someone off the market. You have to be aware of these and to know and think about these as part of your overall protection strategy. There's what's called patent term extension. The patent department and the regulatory department are working together, and the patent department says, I will give you up to 5 extra years on your patent if because of regulatory taking a long time, you weren't able to market your product till later. That's called patent term extension. You want to think about that when you're planning to say, the patent term isn't just 8 years. I get an extra 5 years because my clinical trial was so slow, right? You want to plan for these things. And there's other things like patent linkage, orphan drug status. I don't have time to go into all this. Suffice it to say that the medical area is very complicated, and when you think about a protection strategy, it involves all of these things. There's lots of calculations and there's lots of things to consider. It's not just, how long is my patent term and I'm all set. We're working with humans, right? So there's also human data privacy, and that's a complicated area. As you probably know, mainland China has very strict rules. Hong Kong has an interesting special status in certain ways when we may access a bit more of mainland Chinese, data, but still at the same time, there's a lot of care that needs to be done. There's a lot of rules and laws surrounding this, and you don't want to be misusing data when you're not supposed to, because that could impact a lot of different things. And that's all I'll say about that as right now. And of course, nowadays, right, it used to be that the biomedical side didn't have to think as much about computers, but, I think in this area, of course, that's been a big focus, right, about how are we using AI, how are we using algorithms, and I won't focus too much on that aspect of it, but again, an algorithm is an abstract idea. It is, just like naturally occurring things, is not allowed to be patented. It's called not eligible subject matter. But, of course, there's a lot of software inventions and that they get protected, right? How do you do that? And again, it is knowing how to draft your patent applications and your claims in a way that makes it tangible, solving actual world problems, having examples of using real world data, right? So that is really the key. So in this kind of biomedical space, when we're working with naturally occurring biology, unpredictability, and then, software, algorithms, there is a lot of complex IP issues that you have to think about. So let me switch gears and talk briefly just about public disclosures, because it is such a common problem that I see that I do want to mention it. Some of you may know this already, because a lot of people do know that public disclosures can hurt your ability to be patented. And this involves your own public disclosure. And this is what some people kind of get a little upset about. They're like, but it's my publication. Why aren't I allowed to own it? Well, the whole point of patents is to promote the sharing of ideas such that we can build off of each other, right? In exchange for sharing it, publishing it, you can get a 20-year exclusivity. Therefore, others can learn off of you. But if you publish it voluntarily without for free, essentially, why would the government then want to entice you to give you 20 years of exclusivity if you've already published it, right? That's why even if it's your own and you've published it, you've kind of donated it to the public in that sense. So if you want to protect yourself, file first and then publish. So I just want to put it out there, and that could include things like pitch competitions, press releases, submissions to the FDA, even, clinicaltrials.gov. There's a lot of places where there might be actually, public disclosures that could hurt your ability to be patented later. What I hope you guys can think about if you are doing pitches and such is that think about whether you need to disclose everything. A lot of pitches are very well done by just showing the final results, but they hide the actual, whether it's the drug or the technology. There's just a big black box around it, and they say, I will show you if you sign an NDA. And of course, for public disclosures, these are statements as well. It's not just the statement to the FDA and the statement to the government. Any publication you put out there is counted as your statement of what is true. So make sure there's consistency between your academic publication and your patent applications as well. It's all going to be used whenever there's a litigation and millions of dollars are at stake. So let me talk briefly about the Greater Bay Area, because we are here, and there are many challenges that come uniquely because we work in an area where there's multiple jurisdictions. So just for clarification, first of all, the Greater Bay Area consists of 3 different jurisdictions, right? There's mainland China, there's Macau and Hong Kong SARs. And each jurisdiction has its own rules, its own laws, its own patents. So some people think, oh, I got a Chinese patent. Shouldn't that work in Hong Kong? No, it doesn't. They can still infringe in Hong Kong. Hong Kong has its own patents, and you have to get a separate Hong Kong patent. And if you miss the deadline to file in Hong Kong, then we in Hong Kong can infringe as freely as we want. We're not infringing, actually. There's just no patent here. And people sometimes forget about Hong Kong, actually. This is an interesting place to live, actually, because there really might not be patents on certain things, because people sometimes forget that they have to file in Hong Kong. So these are 3 separate jurisdictions. So if you want patent protection, first of all, you have to just be aware that you need to file for patents in all 3 areas if you want to sell, make, use, or stop people from copying. That's the first one. But secondly, there's this idea of export controls. So this is the concept that if I invent something in a particular territory, then that government gets to check first to make sure I'm not disclosing any national secrets before I'm allowed to file a patent application elsewhere. So for example, China and US both have export control rules. It's called, you have to get a foreign filing license. So if I am living in China, let's say I'm in Shenzhen or something like that, and I make an invention, and then I want to file my first application, I should file in China first because China wants to look at it first to make sure it's okay. US is the same way. And then if I don't and I file, let's say I file a US provisional first, even though I invented it in China, that's violating this export control rule. This violating because you didn't get a foreign filing license. If they find that out, you will never be able to get a patent in China. You have violated the export control and you can't go back. It's not reversible. So you don't want to mess that up because then you are literally hurting your rights ever to get a patent in China. The same goes for the US. If you're in the US and you happen to invent there or you collaborate with a professor that's at Hopkins, or Harvard or somewhere, and then you guys file in China first and you didn't get a US foreign filing license, you violated the same thing. So again, in this tricky area of the Greater Bay Area where we are collaborating with universities around the world, we have to be very, very, very careful. And I will say that this foreign filing license is based on different factors. So US and China base it on territory, but some places will base it on residency of an inventor. So if you have a resident of Singapore, for example, you better make sure you ask Singapore first for permission before you can file your Singapore invented invention in the US or China. So it gets quite complicated. So all I want to say is the GBA brings its own challenges and you want to be aware of that, which is why getting a strategy very early on, engaging the help of a professional to advise through some of this stuff is so crucial because you could really hurt your chances of getting proper patent protection. And let me talk briefly about inventorship and ownership, because that's another area. So you will have to know the inventors, where they're sitting, and also, maybe what their residency and citizenships are, right, to figure out where to file first. But also, who owns the invention, right? The laws are different for that, too. So in China, for example, if you're working for a company, that IP might directly be owned by the company. But if you're in the US, it'll be owned by the inventor first, and the inventor has to assign his rights. This can get really complicated if you're thinking about, I want to in-license an invention. Who owns it? And did the inventors properly actually assign their rights? What's the law of that jurisdiction? So I won't go into detail, but I will say, let's assume you have a situation where you have 3 sets of parties inventing together over Zoom. oh my gosh, where do we file first? Who's the inventor? Who owns the IP? It can get really, really complicated if you base it purely on the law, right? Ideally, you would have signed a lovely agreement before you started inventing, and then it would all be clarified. But sometimes that doesn't happen. So in short, I wanted to wrap up by saying that, I hope I've given you some examples to tell you why it is so important, especially in this field of biomedical technologies, right? That you really need a well thought out strategy because you want to think about the different countries, the different jurisdictions we're working about, the different public disclosures. When can I publish? When do I need to file? When am I doing clinical trials? When am I going to have data? Because I need data for the patent application. What are my business? How much money do I have? Patents are expensive. Is there a way I can push off the costs? Yes. If you get the right strategy, you don't want to just say, I need to wait because I have no funding, and then you miss certain deadlines, and now you've, filed in the wrong country, or you lost your chances and stuff. So you really just need a good IP strategy for all this. And thank you. I just wanted to end by saying, I work at a firm where we feel like we are the bridge, and this is our logo. We are a bridge because we feel like it is important for various sides to connect. I'm I guess you could say, Boston-based Taiwan heritage, living in Hong Kong American, here with the rest of you in the Greater Bay Area. And I hope that I can help you guys bridge the gap between all of these different areas, between technology, IP, between East, West, and everything. So thank you so much for your time. And please connect with me on these different platforms. I look forward to hearing the rest of what everyone else has to say here today. Thank you.
Thank you very much, Jennifer. Please remain on stage. And let's leave with that small token of our gratitude for your wonderful sharing. Thank you very much.